Oke, bismillahirrahmanirrahim. Sebelumnya saya selalu dilema kalau diundang memberikan seminar di Indonesia. Saya harus memberikan presentasi dalam bahasa Inggris atau bahasa Indonesia ya. Atau boleh dua-duanya?
Boleh itu.
Boleh dituliskan di chat box atau boleh terus menginterview. Alright. Bismillahirrahmanirrahim. Thank you, Pak Rusli, for the introduction, the kind introductions, our moderator for this morning. Assalamualaikum and very good morning, everyone. How are you? Apa kabar? Semua sehat?
Alhamdulillah sehat.
Alhamdulillah. Okay. So let me introduce myself. My name is Andri Kusbiantoro, but you can call me Andri. I work in the Department of Civil Engineering Technology, Faculty of Engineering Technology, University Tun Hussein, Malaysia. So my topic today will focus more on the green construction in Malaysia. And hopefully by the end of this seminar, we can learn together about the construction industry in both Indonesia and Malaysia. So it's been a long time for me to follow the construction industry in Indonesia. The last time I worked with Adikarya was in 2007 until 2008, if I'm not mistaken. So if any of you has a question later on, just interrupt me at any time or write it in the chat box. Okay, so people say, tak kenal maka tak sayang. Right. Allow me to tell a bit story about myself. I graduated from ITS in 2006. And after that, Alhamdulillah, I got a scholarship to pursue Master of Science and PhD in University Technology Petronas. Complete my PhD, I joined University Malaysia Pahang in 2001. And just before the pandemic started in 2020, I moved to Johor to join University Tun Hussein, Malaysia. Right. I love to research anything related to concrete, especially those related to cement, pozzolan, or geopolymer. And the latest one, I'm trying to develop a non-destructive method to evaluate the compressive strength of concrete from different perspectives. I've also secured some funding before, not much. It's not much if you compare to all the professors out there. But Alhamdulillah, the funding is sufficient to fund the experiment of my master and PhD students. Right. Okay, we are starting with the main business right now. The keyword of our seminar today is green and sustainability. Why everyone is so fuzzy about these keywords? We have to go green lah, we have to be sustainable lah, and then we have to be environmentally friendly. Let's look at the pictures in here. These images show a very harsh environment of a desert, right? And then a heavy polluted smoke, and then river pollutions, sea pollution that affects the fauna living there. For example, the pelican bird over there, coated with oil. And then let's compare them to these images. All right, we have a green scenery, we have a green mountain, a cool trees, a clean water, and then the healthy ecology. So what are the reasons to all those fuzzy requests before? There are two reasons. The first one, because it is our nature, right? It is our nature to love the cleanliness. I believe most of us who attend the seminar today will prefer the second set of these images to describe a beauty, right? The next same reason, it is our nature, right? This is where we live, this is our home. Who else will take care of it if not us? Okay. And for the next part, right, I would like to bring our perspective. Let's shift our perspective for a while. I want to cite one usul fiqh in Islam that we always hear. Niat tidak menghalalkan cara, right? So the end never justify the means or the way. In here, I would like to use the example from Alan Savory. So in 1960s, he was given an assignment to solve the land desertification in the area that is now known as Zambia in Africa over there. So by using the elephant as the main cause to the desertifications, desertification means the green land suddenly become like a desert, become very dry, right? So using the elephant as the main cause to this desertification, What did they do in the next year? They killed 40,000 elephants, right? 40,000. Can you imagine how much is that? But what happened? Did it bring any positive impact to the land? A big no, right? Fortunately, learn from his mistake, Alan took a different approach that mimicked the concept from nature, right? Which is natural grazing atau peternakan alami, right? So from this natural grazing, this herd of cattle were left at certain area to feed from the nature, right? After considered enough, these animals will be brought to another area. All the damaged grass, all the branches, dungs will be left over there. Kita lihat banyak rumput, kemudian kotoran-kotoran sapi dibiarkan di situ. And then what happened? Amazingly, the area seemed stimulated to grow faster. Right? The example over here, this is the area just before the cattle were moved to the other area, and then what happened next? The green grass starting to grow. This area with the certification and after the natural grazing, you can see some grass has grown over there. And the most radical result, as you can see, this is the area with lake over here. You can see very dry without any grass. And after he used the method, you can see all the the veggies over there, all the trees, all the grass. It's so amazing, right? Wait, hold on. Okay, the next example in here came from our neighboring continent, Australia. In 1930s, Australia had a big problem with cane beetle, kumbang tebu, right? Like shown in this image. This problem considered big at the time because sugarcane was the main agricultural commodity at the time in Australia. But the government didn't want to use pesticide due to the negative impact to the environment. So what did they do? What did they do? They decided to eliminate the pest by importing its natural predator. What is the natural predator? The crane frog, atau the cane toad. What happened next was beyond their imaginations. These frogs reproduce very fast and they are poisonous. Right? Since this frog was imported from outside Australia, from Hawaii, if I'm not mistaken, we don't have any natural predator in Australia. And I believe till today, this species of frog still give them a big headache. Right? Another famous story about the knocking sound in the old engine car. In Indonesia, normally it's always called as a suara ketukan. Right? It's a knocking sound. For the young generation, maybe you never heard about it, but if you ask your father or maybe your grandfather after the seminar, you will know about it. Okay. So in 1920s, there was a man named Thomas Mitchley. Right? This Mitchley proposed to add a chemical substance to contain the knocking sound. But this chemical substance is containing lead. Right? So you can imagine how many years we have inhaled the emission containing lead from all the road activities during our daily life. And you can also imagine what is the effect to our body after they have been accumulated for a certain period. So you can imagine we inhaling the lead, the timah hitam. But Alhamdulillah, I believe Pertamina has stopped using this kind of gasoline since 2006, if I'm not mistaken. The same person also suggests to use chlorofluorocarbon gas, or CFC, as the refrigerant in the fridge. Right. The story was started when there were too many people died from being poisoned by the leaked refrigerant gas rather than from the spoiled food from the fridge. So General Motors, as the main manufacturer of the refrigerator at the time, formed a team that also has Mitchley Jr., the one who proposing the lead. Short story, the CFC has become phenomenal and have been used by many people. Right? You can find it in the fridge, you can find it in the air conditioner, you can find it even in the hairspray at the time. Only until 1970s, two young scientists found the relation of CFC with the ozone hole in our atmosphere. Right. Since then, the use of CSP has been significantly reduced, and even some government has banned the use of CFC in the home appliances. So what I'm trying to say over here, right, our intention might be good at the time, right? But it might lead to different consequences in the future. That's why we have to work together to solve this complex problem. A civil engineer do not work only with your own people, with our own people. So we have to collaborate with others. So we have to avoid thinking simple to solve a big problem. If I can cite from Einstein, complex problem cannot be solved by using the same level of thinking that created them. Okay? Because we are living in one Earth, right? So Earth is a very complex ecosystem. One damaged part in our Earth will be connected to the other part. In our field of expertise, if we, let's say, remove limestone to be converted into cement, right, it will be equal to the loss of ecosystem. But we're not talking about ourselves. We are talking about the living animals. We are living about the living ecosystem stay in that limestone ecosystem, right? It's going to lower the quality of our air and any other negative impact to the environment. So rather than we are trying to make Mars like an Earth, why don't we try to stop turning our Earth into the Mars, right? So from here, let's make the sustainability as the catalyst for many new innovations. It doesn't matter which route you want to take, by doing reverse engineering, by designing a new green product. Let's think for many sustainable ways. And let's put the option to move to the other planet as the last option, at least for the time being, right? And talking about the constructions, how far actually the construction has affected our environment. As seen in the graph, 50% of our natural resource problem came from construction activity, right? But again, it's really unavoidable. Unless we are aiming to live in a cave, then we can only aim to reduce the impact right now, right? If you really want to stop all this activity, then kita harus tinggal di gua, okay? Right? But we cannot aim to live in a cave. We can only reduce the impact right now, right? Again, and then our construction activity also contributed to the construction waste. 20% of the overall landfill waste was contributed by our field of expertise, and then 12% of water consumptions for making concrete, for clearing the construction site, and the release of airborne particulates, the small particles into our breathing air. And also, let's not forget about the greenhouse gases and the massive energy consumptions. Right. So, how far the construction industry in Malaysia has moved to implement the green technology concept? The big question before that is, who is going to certify that my building is green, right? Who is going to, who have the right to decide that kind of claim? Of course, I cannot make my own claim. For example, I build a structure by using green concrete, and then I claim my building is green since my concrete used recycled product inside it. It is not that easy. There should be a legal body, right? What is the body? The body is called Green Building Index in Malaysia. There are 7 types of construction that can be certified. NRNC is a non-residential new constructions, and then the non-residential existing building, and then residential constructions in township and interior. Right. From the business perspective, there will always pro and con. The policy maker, there will always pro and cons. But the government trying to improve or enhance the green agenda, so they are giving the incentive to the business player. Hopefully, by doing that, we will increase the number of participants from the industry in the future. So it will help the nation's sustainability agenda later on. Right. This is not free, but it is hoped that the increasing awareness from the public, right, for the green necessity to produce a green product and everything, the cost can be covered by the consumer preference on their own product. Right. In GBI, there are four levels of certificate. The first one is platinum. You cannot really see my screen. It's cut over there. What about now? Is it better? Okay, hopefully it's better.
Yeah.
Right. In GBI certification, there are four levels of certificate: the platinum, gold, silver, and certified. Right. The evaluation items are the same for each type of construction except for the township. Right. The difference is only at the ratio of the marking. For example, in non-residential, the highest allocation will be given to the energy consumptions, and then followed with the indoor environmental quality. While for the residential, the priority goes to the site planning and management. After that, followed by the energy efficiency. Some of the example of green building in Malaysia. In here is the Eco Terrace, a residential area in Penang. It obtained silver. And then we have over here is Bangunan Suruhanjaya Tenaga, or Energy Commission Building. It has the highest level, which is platinum. It is normal because these commissions, this Suruhanjaya is the one that oversee all the green energy initiative. Right. Other than that, we have IKEA building, where IKEA building obtained gold. And we have Harriet Ward University. You can see it's using green roof on the university, but the Harriet Ward, if I'm not mistaken, reached the level of certified. Right. So for the seminar today, due to the time limitation, I will only discuss the two elements of this GBI index. Right. I will only discuss on the two types. The first one is about the construction management, the sustainable site planning and management. And the other one will be the material and resources. Right. In the sustainable site planning and management, it is divided into four items, which is the site planning, and then the construction management. Next is the transportation, and the other one is design. While for the material, the evaluation mark is divided into first, reuse and recycled materials. Next, how far the project use sustainable resources, and how the project will manage the waste. And finally, for the non-residential area, what kind of green product that will be used in the operation of the building later on. Right. So how we should select our site locations to secure a mark in GBI. First, it should not be from the location of prime and fertile agricultural land. So if, let's say, that area has been decided to be planted rice, and rice is the main commodity in that area because rice cannot be planted at the other area because it's not that fertile. So that kind of prime agricultural land should not be built if you want to obtain GBI marks. Right. And next, it should not be the habitat of the endangered species, nor the wetland. Right. You cannot build a new structure on the wetlands. So why wetland is considered important? Because many research have stated that the wetland actually has better capability to trap the carbon than the forest. But if the wetland is changed into a factory, the role of wetland to trap the carbon will be diverted into carbon producer. What about the project that will use a public park on the right side over here? Right. If it is really important to construct on that locations, on that particular locations, then they still can do it. But the area must be replaced with a new area in other location with at least the same value. If let's say one area have a lot of trees and you want to convert those trees into building, another area with the same trees must be replaced, must be given to replace the used area, right? And it's also prohibited to build a structure on a risky area. For example, over here in class 4 land, which is a land with a very steep, right? And on GBIs, a construction project will be more valuable if built on a brownfield land, such as the dumpster area or a land with the existing building on it, right? The use of this kind of land will help to ease the burden on the environment. And next, the evaluation will also see how the construction is connected to the other infrastructures or nearby communities. For example, if I want to build a residential area, it has to be connected to the nearest clinic or hospital. It has to be well connected to the school. It must be having a good access to market and others. Right. Higher marks will be given if within 1 kilometer of the walking radius, for example, the area is well connected to any modes of transportation, like LRT, MRT, or maybe a bus stop. Okay. And the requirement of open space will also follow the local policy in every state. For example, in Johor, right? Let's say Johor has stated that the open space is, for example, let's say 40%. If an additional 25% is added to the existing open space, then a GBI point will be obtained. But if, let's say, Johor doesn't have any open space requirement, to obtain the GBI score for open space, my project must have the same area of open space to the building area. Price will be equal. Okay, next one is about managing the pollutions. Right. So in managing the pollutions, actually we are talking about the construction management aspect, but the focus is more onto the pollution management. Right. In here, you can see every time we have a ground construction activity, it will be automatically considered as a disturbing activity until a permanent building has been built on the ground, right, to cover the ground. So it should be carefully planned how the sediment flow will happen. We don't want the sediment to suddenly end up in the local drainage like this and increasing the flood risk of that area. Right? Here is the one of the example how this is the example of how the sedimentation and erosion plan being implemented. And you can see we are trying so hard to prevent the sediment to flow into the local drainage. All right, moving to the next slide. Among the annoying problem when working on site is the dust. So if you look the Sinetron, all right, do not trust the Sinetron if one engineer came to the site using a yellow helmet instead of white helmet and then pretend to read a drawing, right? Dia buka kertas lebar-lebar di site. Do not trust that because actually all the engineers on site is covered with sweat and dust, right? It doesn't mean at site there is no handsome engineer. All engineer on site is handsome, right? Believe me. They just covered with dust and sweat, right? So the evaluation will see if there are any efforts that has been made to reduce the dust, either by spraying with water over here, or using the polymer product, or by using seeding and what you call it, techifier, right? Seeding and techifying, where we plant the grass and then techify it or glue it to the ground by using special material, right? We call it a seeding and techifier. Okay, next one we're going to talk about the worker site amenities. Okay, if we see how they stay on the construction site, very concerning, sangat kasihan. Right? They sleep like a sardine, ikan sarden dalam kaleng, ikan sarden ABC itu. Right? They sleep like sardine, and then it's aggravated with the hygiene and health issue. So that's why everything has been exposed during the COVID. Actually, COVID bringing one good impact on the worker site amenities because why? Only during the COVID, suddenly there are so many COVID cases in the construction site. And then when the government look at the site condition, they decided all the construction site must be having a very well managed site amenities, right? The site, the accommodation that is habitable, not the container. Suddenly you ask all the workers to stay inside there, right? So that's one of the good thing, the good impact from having the pandemic restrictions. And the last part that I want to cover is about the heat island effect. Okay, so what is the heat island effect? Is the accumulation of heat on one particular area, right? So the changes from suburb to the urban area are very obvious, which is the change of its landscape. In the urban area, in the city area, the landscape is very clear. If not concrete, then it's asphalt. The lack of wet ground surface due to the concrete drainage is transferring all the liquid, all the water, storm water, immediately to the main drainage channel. So it doesn't even have time to seep into the ground. And then the dark color of the road network, and then the economic activities, all these aspects will contribute to the heat island effect in that particular city. And again, I have to repeat that it's going to be quite impossible to stop this urban development, but at least we can start to minimize it. So if let's say you want to obtain the GBI mark in this aspect, you can start using open grid pavement. So instead of solid concrete, try to use open grid pavement like we have over here. So at least the rainwater has enough time to seep into the ground and cool down the ground over there. Right? And then to install the green roof like the Harriet Ward University over here is also considered as a part of the green management in GBI evaluations. Okay, before we continue to the next slide, is there any complaint to my presentations? Am I being too fast or maybe too slow?
Okay.
It's enough.
Everything nice?
Okay, Prof.
All right, okay.
Can go on.
Okay then, so let's continue to the next part. In here, we're going to discuss about the material and other resources that are used in the constructions. I believe you have been very familiar with these three prime materials in civil construction, which are concrete, steel, and timber. But how GBI will look at these green materials? The first one is how much the material can be reused or recycled. Right? Actually, the material can be divided into two definitions, which are pre-consumer and post-consumer. In the pre-consumer is material that are disposed before they are used by the consumer, such as sodas, and then oil palm shell, and then iron slag, fly ash. And then the post-consumer materials are the used furniture, and then the construction waste, or if you have used newspaper, it's considered as a post-consumer materials. So the purpose of using those materials are to reduce the carbon footprint. So every construction activity that we do actually will produce carbon footprint, especially carbon dioxide. And then we go with the concrete mixing. After that, we transport the material. Even after the building has been erected and fully operational, we cannot really move away from releasing carbon footprint. Right. Therefore, one of the aim of GBI is to reduce the carbon footprint, particularly from transportation perspective. For example, if we ordering a material from China, right? We have to keep in mind that to bring the material to our site, they might use plane cargo or maybe ship container, right? So these two vehicles produces a significant amount of carbon footprint. So that's why in GBI, more marking, so more points can be obtained if we are using local sources, right? For example, we obtain the cement from local state, from Malaysia, right? Or if we can't really obtain the material from Malaysia, we try to get it from the neighboring region. At least we are trying to reduce the carbon footprint, right? Special for timber, if we are trying to use the timber in our structure, there is additional requirement where the timber must be cut from the certified forest. So it's not from any forest. So if the timber was obtained from the certified forest, then we can claim for GBI point, right? So same in Malaysia, like in Indonesia, Malaysia has the abundant amount of limestone sources. So it makes the price of cement to be not that expensive. one bag is about 18 to 20 ringgit, or about 54,000 sampai 60,000 rupiah. Okay. So this abundant amount of limestone has made concrete to be the most favorable material for the construction because it's cheap. Even though later on in the construction we have to combine concrete with reinforcing steel due to the brittle characteristic, but because of its cheap, it is durable, it is having low maintenance cost, and it is modifiable. It makes concrete very attractive, especially the modifiable characteristic, right? Because why? The modifiable characteristic also make concrete to be the most favorable material to be studied by many researchers, right? Now, sky is the limit. What does it mean with sky is the limit? You can study about everything by using concrete. I give you an example from four main components in here, right? We have cement, water, aggregates, and mixture. Right? From these four components, all researchers right now is trying to replace with a new material. Right? This new material is normally taken from the industrial waste to enhance its sustainability value. For example, cement over here. Right. The replacement material that are commonly found in the literature are fly ash, and then fly ash from the coal-fired power plant, and then the ground granulated blast furnace slag from the iron industry, and then silica fume from silicon alloy industry. And we're going to hear from Associate Professor Dr. Suraya later on about palm oil fuel ash. It's a famous pozolan in Malaysia because we have such a big production of palm oil annually, so it means it's going to generate a big amount of waste as well. And then another potential material is rice husk ash and also the sugarcane bagasse ash. Right. As for the water, I ever reviewed a journal where the author used the wastewater from hospital. Right. It is very unusual, especially during the pandemic era right now. But again, as I said, sky is the limit. Right. And for the aggregate replacement, it has more variations like bottom ash, clinker, recycled concrete, oil palm shell, egg shell, even cockle shell, kulit kerang. Right. So the student who did the project at the time, they have two lives. In the morning, they are student, but in the morning, they become garbage collector atau pengepul sampah. Right. They will come to the seafood restaurant to collect the cockle shell, or they will go to the bakery to collect the eggshell. But the results were very interesting because the strength was higher than control. And for the additive, my student at that time will go to the car workshop, bengkel mobil, to ask for the used engine oil. So this used engine oil will be used as the alternative to plasticizer to enhance the concrete workability. Okay. Some people will find it ridiculous because why you have to use waste? Why you just put everything in concrete? Right. But do not forget that this basic thing that initiated the research of fly ash and silica fume, where they will be used to construct the KLCC Twin Tower and Burj Khalifa in Dubai. Right. So to achieve the compressive strength of 80 megapascal, it's quite impossible to be achieved by using a normal concrete only at the time. So the KLCC Twin Tower used a mixture of fly ash, silica fume, and cement in their concrete. The same with Burj Khalifa, they are using the same material. Right. So even though these two even though these two buildings still use super plasticizer due to very low water smell ratio, perhaps in the future there will be a building constructed in Semarang using concrete containing eggshell or cockle shell that was previously studied in Unissula. Right. Who knows, right?
Jam 11. Apa habis piknik malah? Betul.
Any questions?
Saya
Okay, no. All right. Sorry, I was being mute just now. Okay. Sorry for the interruptions. Okay, so actually, how is the appearance of waste, industrial waste that are suitable for our concrete? So this is how the fly ash looks like. All right. If I'm not mistaken, the nearest power plant from Unissula is in Jepara, right? In Jepara atau Batang. If I'm not mistaken, you have a coal-fired power plant over there. And the next famous material is silica fume. It has about more than 90% of silica proportion inside it. Because of that rich silica, it also escalates the price of silica fume to be more expensive than Portland cement. Another material that containing quite a lot of silica proportion inside it is rice husk ash, right? So rather than we open burn the rice husk and export the haze to Malaysia every year, right? Why not we control burning the husk and obtain ashes with silica more than 90%, and you can try to sell it, right? So actually, how the silica will help our concrete? The main principle of hydration is to form calcium silicate hydrate. So these calcium silicate hydrate gels atau CSH gels will act as the main framework in our binder. From the hydration as well, it's not only producing CSH gels, but also producing calcium hydrate. Right. This is where the silica from pozzolan plays the role. So the silica will react with calcium hydrate and forming the secondary calcium silicate hydrate. So the addition of secondary calcium silicate hydrate will help to strengthen our binder despite of the less cement content inside the concrete. Right. However, these pozzolans can only replace the portion of cement in concrete partially. It cannot replace fully cement inside it. To totally replace the portion of cement 100%, you will need geopolymer. It's a new material that gained the popularity. So if any of you want to study or for master or PhD about geopolymer, you can come to UTHM and join with our group, with our team to study about it. The first term of geopolymer was introduced by Joseph Davidovich. There are a few types of geopolymer that are commonly used. The first one, Davidovich used the mixture of metakaolin 750 is a kaolin burned in oven with 750 degrees Celsius, right? And then mixed with slag and alkali silicate. The second type is a rock-based geopolymer cement, still using the same proportion like in the first type, but Davidovich add the volcanic rafts or volcanic materials and mine tailings, the sideways of mine activity. The third type of geopolymer is the most famous one, since it is easy to be reproduced and studied. It uses fly ash combined with sodium hydroxide plus sodium silicate, or you can combine fly ash with slag and mix with sodium silicate. And the fourth type is a ferrosilate base. Again, Davidovich using the same basic mixture in the first one, but this time he combined it with high iron oxide geological material. So since geopolymer is relatively new if you compare it to the cement, the most commonly asked questions, is there any building that has been built using this material? The answer is yes, there are, but most of them are located in Australia. The first one is the Global Change Institute, right? The Global Change Institute building in the University of Queensland, Australia. The floor slab on that building was cast using geopolymer concrete. And then there are several strips of runway in Wellcome Airport, Australia. Okay, they are made by using geopolymer concrete. So rest assured that geopolymer concrete is no longer an experimental concrete, but it has been a commercial concrete. And perhaps one day there will be a geopolymer concrete supplier from this class in Unissula, right? Inshallah. And as a closure, a project will also be evaluated how they will handle the construction waste. There will be a detailed plan showing the type and the amount of disposed or recycled materials, where you can see in here. All right, so thank you for your attention. There are more slides in here, but I think better I stop it till here. And inshallah, we will continue it again next time. And with that, I return the session to Pak Rusli.